All right, good morning.
Morning.
All right, let's see. Questions? All right, so I've had some people coming into office this morning to work on their stick program, and looks like people were in pretty good shape. So hopefully everybody's got stick under control. But this is a really good time to ask if you've got lingering issues. I'm probably not going to be answering emails this afternoon. Um, so anything that's not making sense.
Will that also mean you're not reading emails this afternoon?
I might peek in on them once in a while, but if I start responding to emails, that's going to be all I do for the rest of the day, and I've got other things I need to do. So I would
This
prefer to
this
do
is actually
things.
outside of this class, but I just wanted to send you an email saying, hey, my homework one for CSE215 was like 1 minute late. I want to use my late pass from that.
Okay, yeah, go ahead and send an email.
Thank you.
I read my emails eventually, but sometimes I have to leave them until the next day when I'm in office. All right. Well, let's talk more about pipes then. So remember our basic setup here, right? We can run a command and send the output into a file, or we can run a command and read the input from a file. And so we could potentially, take the output of one command and analyze it with another command. Um, and using temporary files is okay, but it's not a great thing to have to do. And so there's a mechanism called a pipe that lets us just say, hey, let's run command 1 and let's run command 2 and let's connect them together. And so standard out of this command is fed into standard in of that command. And so we can put these commands together like that. All right, go ahead and send me an attendance note. Let me know you are here. And let's look at this. So, one command that we'll encounter a fair amount is the word count command. And WC basically just tells me how many things are being sent to standard in. So if you look at the manual page, print new line, word, and byte counts for each file, right? So basically this will either take a file or, if no file is specified, read from standard input. So what does this mean? If I say word count and I say hello, this is a test, cool, goodbye. All right, and I'm going to hit ctrl-D to signify this is the end of my input. And word count prints out 3 things, a 3, a 7, and a 35. So what? 3. 1, 2, 3 lines. My audio just freaked out, but I think it's back. All right, so 3 lines of output. That's what that 3 is. 7 words of output. This is a test, cool, goodbye, and hello. That's the 7. And 35 is the total number of characters in all the stuff that I typed in. So word count is a general tool we can use to count the number of things that are sent to standard in. And so, for example, I could say ls and see how many files I have in my directory. I could count them: 1, 2, 3, 4, 5, 6, 7, 8. But if I just take ls and I pipe it into word count, there's my 8 telling me, hey, I got 8 files in my directory.
don't you have to hit ctrl-D for that one?
Because the ls command generates this output, and when it's done generating output, the ls command exits. And that basically says that's the end of the input. And that's what ctrl-D does when I'm typing. It says end of file.
Okay, so if you're using it with another command, then the command is already exiting or...
Yeah, it's effectively sending a ctrl-D. It doesn't do that, but that's the effect of it. Yep.
Okay.
Contrastly, you could also use a EOF string to close it in this case.
Actually not. So EOF will just be another line of input. So Control-D is funny, right? And this will come up later, but we can touch base on it right now. Control-D is just a convention, right? If I hit a Control-D right here, I'm not actually sending a Control-D to standard in. And word count is not looking for a Control-D. Control-D is something that Bash, which is managing this whole operation here, when it sees a Control-D, it will say, oh, that's the end of the user's input. And it will do something magical inside so that word count, when it tries to read a line, gets a message saying, oh, we've hit the end of the input. But it's just a trick. And I can change this. I could change, Control-W to be end of file. And then I could use a Control-W to end my input. It's just something that's being set up by Bash as a way for me at the keyboard to be able to signify to a command that you've hit the end of the input. And if I say word count and I give it the name of a file, like bad.c, word count will open that file, start reading lines from it, and when it can't read anymore, that's, the end of the file. And it does the same thing as if I had hit Control-D or a command I piped into there exited. The two less than sign is a different creature, though. Man, my microphone is having a hard time. The two less than sign lets you move down in your script and put that tag there, EOF, and then ingest the stuff in between. I haven't gone over that yet, but it looks like you know what you're doing with that. So yeah. All right. So when we start talking about C, we'll readdress this idea of end of file, and it'll make a little more sense in C, I think. So I can use the command who, and I can see who's logged into my machine, and it's some joker called Nick is logged in 5 times. If I do who and I pipe it into word count, there's my 5 that tells me 5 people are logged in. And if I log in again and I do a who and pipe it into word count, now there's 6 people logged in. And if I log out, we're back to 5. Now word count shows me 3 pieces of information: number of lines, number of words, number of characters. And there's a switch I can put on word count that says just show me the number of lines. And if I read the manual page, I'll see if I do a -L, it says print the new line counts. So I could do this and I could pipe it into word count -L and just get a nice number 5. But I don't know about the -L switch. I only know about word count, which prints out 3 things, but here's something I do know. I know about another command called awk. And awk we'll talk about later on in the course, but a simple way to use awk is to say something like quote curly bracket print $1. And what this command does is it takes standard in and it prints out the first word from each line, in this case this. Hello world just prints out hello. 1, 2, 3, 4, 5 just prints out 1. And so if I take who and I put that into word count and I put that into awk, that just tells me how many people are logged into the system. So we want to start thinking in this mindset of putting together tools to do something. Right? These are like Lego blocks. This is like redstone in Minecraft, right? It's really simple behaviors. Count the number of words, lines, and characters. print the first thing on each line, show me who's logged into the system. But by putting these together in the right way, we can get more complex behaviors. Right? So I want to know what month it is. Well, there's a command called date, which shows me, you know, a whole string of information. The second field on that is the month. So if I take date and I pipe it into awk, print $2, it shows me that it's, or $2, it shows me that it's September. If I do this, it'll show me what my time zone is. If I do this, it'll show me what year I'm in. And I can look at the date command, and there's all sorts of switches I can use to do all sorts of things, including show me what the month is, show me what the year is, show me what my time zone is. But if I don't want to learn all of this stuff, right, but I know how to use awk and I know how to use pipes, it's really easy to pull out the year by doing this. So there's 2 points in a spectrum of possibility here. There's learning every command and every switch that can modify every command, and, you know, turning yourself into a walking Linux encyclopedia, which is really hard. Or there's learning, you know, 15, 20 commands and getting good at putting them together, right? Which I think is a lot easier. And it's also more fun. It's kind of fun to, like, you know, do these little puzzles throughout the day. How do I get this? How do I get that? All right, so pipes are going to be useful for us. So let me shift gears. Let me talk about a different kind of quotation mark, a backwards quotation mark. And so we know we can use double quotes to, you know, make things look a certain way. We know we can use single quotation marks. These are the ones on the same key usually as the double quote. And single quotation marks will let us do things like, you know, print a $sign and actually have the $sign appear. So if I print single quote $X, it will print a $sign followed by an X. If I print double quote $X, it will evaluate what X is equal to and print that out. So we've seen those before, but there's another kind of quote. It's called a back quote. And on my keyboard, it's in the upper left corner next to the tilde. And a back quote does something very strange. So if I say back quote some command, and it can be a simple command, it can be a big long command, it can have pipes in it, it can do all kinds of things. When I say back quote some command, 2 things happen. First thing, this command is executed. But the results of that command, the output this sends to standard out, I don't see that. It doesn't come to my display, it doesn't go into a file, it doesn't go into a pipe. Instead, imagine that this whole expression, back quote some command back quote, is effectively replaced by the output of this command. And suppose I say X equals back quote date. Okay, the date command is going to be executed. It's going to say Thursday, September 30th, blah, 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 blah. And then all of this is going to get replaced by that output. And now bash is going to execute the command X equals Thursday, September 30th, blah, 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 blah. And my variable X will take on that value. All right, so let's explore this. If I say X equals date, and I echo X, it's date. If I say X equals double quote date, and I echo X, it's still date. If I say X equals single quote date, and I echo X, it's still date. But if I say X equals back quote date, and I echo X, it's Thursday, September 30th. So this is really different. And if I said X equals to, you know, backquote date, pipe into awk, print $6, and I echo X, it's equal to 2021. And if I do that, now I've got some code that will tell me what year it's going to be next year. Or if I really want to be kind of bizarre, so bash is easier to write than read, by the way, right? If somebody handed me this and asked me what it does, it would take me, you know, a few minutes of scratching my head to think about it. But writing it, I didn't really have to think very deeply. But what's going on here? I'm executing the date command. I'm taking the output, sending it to this command awk, which says print the 6th field. So 1, 2, 3, 4, 5, 6. And then since all of that is inside backquotes, this backquoted expression gets replaced with a string containing 4 characters, 2021. And now I've got $paren 2021 plus 1. Well, the $paren says do arithmetic. Take 2021 and add 1. And so all of this becomes 2022. And my statement was simply echo 2022. So you see stuff like this, stuff that looks like this all over bash scripts. And again, writing it is about, 10 times easier than reading it. This is why commenting is really useful, because if I put this in a script and I didn't put a comment on it, and I went back to it, a year later, I would have no idea what it was doing. I would probably just close the file and start writing from scratch, rather than try to reverse engineer this. But when you're trying to construct this, if I want to know the current year and add 1 to it, right, you OOTSI your way to there piece by piece. Well, I can use the date command to get the date. I can use awk to get off this field. I can put it in backquotes so I can, replace my expression with that actual value. And then I can put it in $paren and add 1. And then I can put that, inside an echo statement with some information in the beginning. So backquotes are a huge thing to have in your toolbox. And they can be kind of funny. If I said x equal to backquote ls and I echo x, it's a list of my files. If I said x equal to backquote ls-l and I echo my variable x, it's, a big long string of all of this stuff jammed together side by side. So you can get really big variables this way too.
So the backquotes, are they useful in actually programming in Bash, or just when creating commands, scripts and stuff like that?
They're very useful inside Bash scripts themselves, like when you're actually programming in Bash, and they're useful from the command line. And those are kind of the same thing in some ways. I have, a whole bunch of scripts that I use in my daily life when I'm working on a computer, and they're filled with, stuff like this. It turns out to be pretty useful. So I've got, you know, like a script that lets me display things on my screen for a few seconds. And I use this thing called xDoTool that takes an argument, select windows and get mouse location, that will basically let me choose a window by clicking on it, right? And the result is a set of words printed out on a line. Well, I take that and I put the result inside I put the command in back quotes, so the result of that goes into a variable here called coordinates. And then I echo the value of that, and I use something called seds to clean up the format, to basically get rid of colons in that line, and then I use awk to pull fields out of that, and I put all of that inside back quotes, and that gives me my x and y location variables equal to certain fields that were generated by this xDoTool command. And once you've done this enough times and you start thinking in this kind of mindset, this becomes second nature, right? It's just sort of how you view the world that you're working in. And then you can, you know, use that to customize your environment, make yourself shortcuts, tools, things like that. All right, so let's look at wildcards. So, a wildcard is, you know, something that holds the place of other things. And for example, let's see, what directory am I in here? So if I do an ls, right, I've got a bunch of files in here. If I wanted to list all the files that, you know, were C files, I could say ls*.c, and it shows me, you know, I've got one file, bad.c. Well, let me make some new files. Alright, so now I've got a few files in here that are .c files, right? If I say ls*.c, it will only show me the files that basically match anything. Asterisk means any number of characters followed by a period followed by a C. If I want to list all the files that start with the letter F, I could say R, and there's F file and fun test. If I want to list files that have an E anywhere in their name, I could list *E*, and I got 3 files. So wildcards are useful for you know, interacting with files when you want to potentially work with more than one file, and you want to specify the files not by listing their names, but by listing something about their names. So I could say ls-l *E*. I could also have just said, you know, ls-l file fun test and new.c and gotten the same results. But if I know I'm looking for, you know, information on C programs, I can say ls-l *.c, and there we go. I can make a backup directory, and if I want to copy all of my .c files to my backup directory, I could say copy *.c to backup. And now if I go into my backup directory and I do an ls, there's my .c files. If I wanted to copy everything from here into my backup, I could say copy * into backup. And that'll work great, except it's smart enough not to try to copy itself. So it's not going to copy backup into itself. But, you know, now if I go into backup, I've got a copy of all my files. So this star is useful, right? And it works with the copy command. It works with the ls command. It also works with, you know, the word count command. So I can say wc f*, or maybe wc *.c. Where am I? Oh, I changed my directory, never mind. So I can do word count *.c and see how big, you know, all of my C files are. So here's the question. This asterisk, which, somehow matches patterns, and if I say star.c, we'll look at these and say, oh, this and these match that pattern and the others don't. How does the ls command do that? How does it know which files it should list? How does the word count command know which files it should count? How does the copy command know which files it should copy? And the answer is those commands don't know the answers to those questions. Bash does it exactly. So when I say, ls star.c, right, remember this is a command line argument to the ls command, but when the ls command runs, it's not given an asterisk followed by a period c. It's actually given a list of files, bad.c, new.c, old.c. And so typing this and typing this look exactly the same to ls. When the ls command runs, it thinks it's been run with 3 command line arguments. When the cp command is run to copy files, if I say copy star.c, cp thinks it was called with 3 command line arguments. So these wildcards are managed by the shell. And an asterisk matches any number of characters. A question mark matches exactly 1 character. So if I wanted to list all my files with 5 characters in the name, I could say ls and put in 5 question marks. And there's 5 characters. And again, the ls command didn't get this. The ls command ran with this as its list of arguments. And that's really powerful. It means that when you write a script, your script will automatically work with wildcards. And this is why if I say something like, echo asterisk, well, bash sees the asterisk, it replaces it with, the list of files that match this pattern, which is, every file in this directory. And so the echo command is being run as if all of this had been given on the command line, and so it echoes a list of files. And if I don't want that to happen, if I really want an asterisk, that's when I go ahead and I put it inside double quotes. All right, does that make sense? So let's talk about bash functions. So if you have a series of bash statements that are being executed multiple times, you can put those into a function, right? This is how we write functions in C, for example. If you have a C program and you repeatedly need to know if a number is prime, right? Instead of writing, those nested loops that check to see if a number is prime, everywhere that you want to do that, you could make a function called is this number prime? And anytime you've got a number x and you want to know if it's prime, you could just say is this number prime, parentheses x. And maybe the function returns a 1 if it's prime and a 0 if it's not. So functions encourage code reuse, and they encourage the idea of modularization, breaking your code into modules or pieces. And we can do this in bash. But it's a little quirky trying to pass things in, and it's even quirkier trying to get things back. But let's play with this. So let me make a function. Let me make a bash script called cool. All right, suppose for whatever reason I want to know how many people are logged into my system. and I need to do this multiple places throughout my script. So I know how to do this, right? I can do who, I can pipe it into awk, I can print $1. I can take who, I can pipe it into word count, I can pipe that into awk. This set of commands will return the number of people logged into my system. And if I set number equal to backquote that, right, this variable num will be the number of people logged in. All right, so I don't want to write this over and over and over again, so I'm going to make a function. So I'm going to say function, and what should I call it? I don't know, I'll call it count. And I'm going to put in a curly bracket to do the beginning of the function. And I'm just going to say echo $num, and that's the end of my function. All right, so what should I do? I'm just going to say echo number of people logged in, colon. And then I'm just going to call my count function. All right, so this is my main script that's going to run. This is defining a function. Nothing executes when this happens. This is just creating, you know, the function definition. But my actual bash script, first thing it's going to do is echo a message, number of people logged in, and then it's going to call this function count just by saying the name count. And this should execute all of these things, take the result, put it in this variable num, and then echo it out. All right, have a good one. So if I say make this script executable, go ahead and run it, it says number of people logged in 5. All right, so let's make another script cool too. So this is going to be a function to print something a bunch of times. And I'm going to call this function repeat. And let's say we want to print something out 5 times. So I'm going to print out a message, and I'm going to set I equal to I plus 1, and say done. Alright, so I want to print out the word hello 5 times. All I got to do is say repeat, and you know, this will loop 5 times, and this is, you know, something we've already done. Hello, 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 hello. Alright, suppose I wanted to print this a variable number of times. What I'd like to do is say repeat 3 and have it print out hello 3 times instead of 5 times. Well, I've got num hardwired to 5 here. What I'd like to do is somehow have num set equal to, in this case, 3, because I passed a 3. And this works exactly like doing command line arguments to a bash script. If we just use $1, then when this function runs, num will be set equal to, in this case, 3. If I said repeat 17, num would be set equal to 17. So now if I run this, it prints out hello 3 times. If I change this to 7, if I change this to 7, and I run it, it prints out hello 7 times. All right. If I wanted to print an arbitrary message, I could echo $2. And I could put in a second argument when I call my function. Now when my function runs, anywhere that I use $1, that's going to be equal to 7. And anywhere that I see $2, that's going to be equal to COOL. So if I run this, prints out the word cool 7 times. So we can pass arguments to a function like this. And that lets us bundle some behavior. So, you know, thinking about the stick program, right, you could use this when you want to print out that set of pipes followed by a number in parentheses. You could make a function to do that. And you could pass the number of things that you want, the number of times you want to iterate, you know, as an argument here. And this can be, you know, this is just a symbol. So I could do something like this. What shall we say? Read message. Say it how many times. Read a number. And now I could say repeat number of times that message. So I'm calling my repeat function, but the first argument is whatever the user typed in here, and the thing it's going to print is whatever the user typed in here. So now if I run cool2, it says, what shall we say? Yay for Thursdays. And how many times shall we say it? Let's say it 4 times. There you go. Now, a little bit of a side note here, it only said yay. And why is that? Well, because message was equal to yay for Thursdays. And remember, when I called repeat, what I did was repeat for yay for Thursdays. Right? So $2 was the word yay. But if I put this inside quotation marks, the entire message will be $2. So quotation marks are a way to say, even though this stuff has spaces inside, this is all one command line argument. And so now if I run this, I can say yay for Thursdays, and I can do 4 times. Oh no. Did I not save it? Okay, I didn't save it. Yay for today, and let's say it 4 times. There we go. So that's a detail, but just kind of keep in mind when you're doing this stuff that spaces are really, really important in Bash. We know this from writing conditionals and whiles. They're also important because by default, spaces are what break up arguments. And the echo command, you know, if I say echo, this is a test, well, the echo command will take all the command line arguments that I give it and echo them out, right? So echo doesn't matter if I put things in quotation marks or not. But if I wrote a script called echo that should just, you know, echo the first command line argument, this would just echo this. If I put it in quotes, it would echo the whole thing. All right, so getting values back from functions. So back to our count function, right? This counts the number of people who are logged in, and it just echoes it. It just sends it to standard out. So if I run cool, it tells me there's 5 people logged in. If I wanted to do something with that value, like save it in a variable, this is where I can use backquotes. So I could say, you know, num logged in equals backquote count. And now it's going to run the function count, but any output that's produced will get put into this variable. So when this says echo 5, instead of displaying that to standard out, that 5 will basically take the place of this, and this statement will set num logged in equal to 5. And so I could change my echo statement to say there are $num logged in people logged in. So now if I do cool, there are 5 people logged in. So that's how you can work with functions and sort of feed things to a function and get things back from a function. But it's nowhere near as elegant as a typical programming language like C or Java, where you can actually return integers or things like that. Really, all you can do is capture whatever this thing sends to standard out. And so if my function, has a debug message in here, right? Like if I say echo running who, etc. Well, now when I run my function, it says there are running who, etc. 5 people logged in. Right, because this function is producing 2 lines of output. One line is a message, and another line is the actual number. Well, all of that replaced this backquoted expression, and num logged in got set equal to that. So passing things back from functions can be tricky in Bash. And if it's more trouble than it's worth, don't worry about it, right? But for sending things into a function and having a function do something, it's definitely useful. And if you've got something that you just want to have happen, like maybe you want to do a git add star, git commit, git push origin master inside a script, and you want to do that a bunch of times, you can throw that in a function. Call it, push everything. And anytime you want to do that, just say push everything, and it'll run your function. Right, so now I've got a function called all. Anytime I say all, it will try to do my 2 git commands. Well, I don't have a git repository here, but I could. So if I say all, it'll go ahead and it'll add all those files to git, and it'll do a git commit. So functions are useful. All right, and this brings us to a more general topic. Related to how we write code. And you're already doing a lot of this in your stick assignment, right? And in 121 we learned to program in C, and we're writing, maybe we're testing for anagrams or doing something with prime numbers. We do that in 120 sometimes. So we're writing code that usually involves, some conditionals, maybe some looping, and maybe some nesting. Right, so you might have a loop, and inside that loop you might do another loop, and inside that loop you might do an if-then, and that works. But sometimes when you're thinking about the organization of a program, there's ways that you can sort of logically break it into pieces, right? So for example, a lot of programs can be broken into three main pieces. Do some input, do some processing, generate some output. Now some things, take input multiple times while you're running them, but let's say you want to, figure out how many years it's going to take you to pay off your house. So you run a program and you put in, information on your mortgage and the interest rate and monthly payments and all this kind of stuff. It does some processing and it generates an output and says, your house will be paid off in 2,000 years. That's me. So we could think of our function as, or our program as like three pieces, right? And writing this piece might be totally different from writing that piece. This is, hello, welcome to the mortgage calculator program. What's your name? Get some input from the user, save it into variables. Say hello, variable name, right? Processing might be, doing the calculations for compound interest and exponentials and all sorts of stuff like that. And output will be, probably a bunch of print statements or echo statements or something. But our main program, we could write that and it would be 3 lines of code, right? Get some input, do your processing, generate output. That's your whole main program. And so PA1, our stick program, right, could be something like this, right? Start, play game. Well, maybe that's our whole main program in Bash. Do some initialization that deals with how many sticks, who wants to go first, and so on, and then play the game. And maybe play game, I'll pass an argument to that says who should go first. So $first. And then my play game function would be, take a turn, $first, and then first equals adjust $first, and maybe I would put this in a while loop, right? And I could say, see if the game is over, and while the game is not over, do this. And this would be a function that basically takes a U or a C and either, asks the user how many sticks to take or calculates how many sticks the computer takes. And adjust might be a function that takes an argument, that's whose turn it was, and if that argument is a U, it returns a C, and if it's a C, it returns a U. And this one line would alternate, right? If first is equal to U, adjust will output a C, and this will say first equals C, and vice versa. And so this idea of top-down design is pretty powerful. It's basically deferring the harder work to later, right? If this is my main program, I can write this in 1 minute. Start, play a game. Or maybe I'll say something like first equals backquotes start. It tells me who's going to go first. And then pass that to a play game function. Well, that doesn't take a whole lot of thought to write, And maybe making my play game, something like this doesn't take a whole lot of thought. I got to think about what the pieces are, But I haven't done any of the real low-level detail work. But by the time I get to the point where I'm dealing with modulo 4, and if this is bigger than 3, do that, and so on and so forth, I'm working on a tiny little piece of the program. So modularizing does 2 things. It lets us take our big goal, our whole program, and break it into these little pieces, and write it very simply. And then when we get down to the details are nicely packetized. Okay, I have to write a function called, get number of sticks to take. But it's only got to do one thing, right? Find out how many sticks the user wants to take. So in that function, I say how many sticks, I get a number, I see if it's legal. If it is, I'm done. If not, I warn the user and I try again. If it's legal, I'm done. If not, I print an error, right? So that's this idea of top-down design. We'll talk a lot more about that down the road. All right, send me a final attendance note, and we're out of here. I will see you tomorrow. Good luck with stick program. Do what you can. If you can't get it completely done, leave a README in there and just tell me, you know, what part of it is working so that I know how to, you know, grade the parts that do work to give you the most points possible. If you can't get it done, send me an email, take a slip day, come to office hours in the morning. All right, have a good one. I will see you tomorrow.